The following program is brought to you by Copeland Corporation.
Hi, my name is Glenn Hannigan. I'd like to help you understand some of the common causes of compressor failures. When looking into this subject, you have to start with one very interesting fact. Industry records clearly show that replacement compressors, whether they are new or remanufactured, fail at a rate many times greater than compressors going into new systems. This clearly demonstrates that there is often a problem with the system itself. This problem has caused the original compressor to fail and will probably cause the replacement to fail as well. So how do you tell if your failure was caused by a system problem? The answer is inside the failed compressor. You have to open up the compressor and look for the various clues that can show you the true problem. Many failures end with the motor burnout, misleading some technicians into thinking that the root problem was electrical. This just isn't the case. Inspections show that the problem usually starts somewhere else and gets steadily worse until it causes the motor to fail. The blame goes to the motor. The true problem remains. There are 5 main causes of compressor failure: flooded starts, refrigerant floodback, slugging, overheating, and loss of oil. We're going to look at refrigerant floodback in this tape and learn what refrigerant floodback is, what causes it, and what we can do to prevent this problem. Let's watch.
Refrigerant floodback, commonly referred to as simply floodback, occurs when liquid refrigerant flows through the suction line into the compressor during the running cycle. Depending on compressor construction, this liquid refrigerant dilutes the oil on the cylinder walls or in the crankcase and causes the moving parts to wear, seize, or break. In air-cooled compressors such as this one, liquid can move very easily into the cylinders. The suction vapor enters through the suction service valve on the compressor body at the cylinder end. Small amounts of liquid refrigerant may be separated by a decrease in velocity in the vertical passageway, return to the crankcase through oil drain holes, and dilute the oil in the crankcase and cylinders. But the majority of the liquid will be carried by vapor velocity through the suction reed valves and into the cylinders. This liquid will wash the oil off the pistons and cylinder walls during the suction stroke. Even if the heat of compression vaporizes the liquid on the compression stroke, there will still be wearing and scoring of the pistons and cylinder walls. Larger quantities of liquid that cannot be vaporized or squeezed through the discharge reed valve causes a condition known as slugging. In a refrigerant-cooled compressor, the suction vapor enters at the motor end of the compressor, cooling the motor as it passes to the suction valves. Small amounts of liquid refrigerant carried back to the compressor by the vapor are boiled off by the motor heat, causing little harm. During a floodback condition, however, there is too much liquid refrigerant to boil off, and it separates in the motor housing, flowing to the crankcase through the oil check valve where it will dilute the oil in the crankcase. The oil pump will then pump this refrigerant-rich oil to the rod and crankshaft bearings. The heat of friction will boil the refrigerant out of the oil, and there will not be enough volume of oil to reach the rods and bearings furthest from the oil pump. A pattern of wearing, overheating, seizing, and breaking of the running gear components starts at the bearing closest to the oil pump and worsens as it reaches the bearing surfaces furthest from the oil pump. With excessive wear in the motor end and center bearing, the end of the shaft may drop enough to cause rotor drag and result in a shorted or grounded motor. If a failed compressor is not examined for the wear pattern, the true cause of the motor burn may not be known. Floodback commonly occurs when you lose control of the liquid refrigerant being fed into the evaporator. This can be caused by such things as 1. Low evaporator loads or sudden changes in loads. 2. Refrigerant overcharges in a capillary tube system. Or malfunctioning or improperly adjusted thermostatic expansion valves. The first cause, low evaporator loading, may be the result of oversizing the equipment for the actual refrigeration load. It can also be caused when the evaporator cannot pick up heat adequately. Poor heat transfer is often caused externally by a variety of problems brought on by dirt or excessive frost and ice. Locate product to maximize air circulation and make sure you properly place return and supply ducts to prevent air recirculation. Maintain clean filters. Keep grills and air ducts open. Check evaporator fan blades for excessive dirt or motor failure. Oil logging in the evaporator can also lead to poor heat transfer. Proper installation and preventive maintenance, proper control settings, and adequate defrost will solve all of these problems. If you know the evaporators are loaded correctly, the next thing to check is for proper operation of the liquid control devices. On capillary tube systems, make sure that the system is charged correctly. On expansion valves, check for three things: correct superheat settings, correct size selection, and correct application. The first item, the superheat at the outlet of the evaporator, should be checked not only at full load conditions, but also at minimum load conditions, because floodback occurs most frequently during this time. At minimum load condition, the expansion valve often isn't able to respond quickly enough to prevent floodback. Follow the manufacturer's recommendation, because correct evaporator superheat depends on the temperature application. In selecting an expansion valve, choose one for the actual BTU load at the design temperature, not according to the horsepower of the compressor. If an oversized valve is used, floodback will occur every time the valve opens. And finally, expansion valves should be checked for proper installation and operation. A loose or poor connection of the sensing bulb to the outlet of the evaporator, plugged or disconnected external equalizer lines, or foreign material holding the valve open will all cause flooding. The best method of preventing damage to the compressor due to liquid floodback is placing a properly designed accumulator in the suction line right before the compressor. The accumulator must be in a place that is warm enough to vaporize the liquid refrigerant it catches and must not be insulated. Also, it must have a means of returning any oil that it traps. Otherwise, it will fill up and quickly become ineffective. Ideally, liquid refrigerant never finds its way to the compressor. But compressors don't live in an ideal world. Let's look at something. It is true that superheated vapor is liquid-free, and this fact has misled some technicians into believing that as long as they measure a degree or two of superheat coming to the compressor, they will have no problem. Actually, refrigerant floodback can really be avoided by making sure that you have a minimum superheat of at least 20 degrees Fahrenheit in the vapor going into the compressor. Since floodback often takes place at low load conditions in the middle of the night or during erratic running periods, such as in defrost cycles, the technician is usually not present to see the superheat drop and the floodback occur. If a minimum of 20 degrees of superheat is measured during normal load conditions, it is unlikely that liquid will find its way to the compressor during erratic or low load conditions. That's why having 20 degrees of superheat is like having an insurance policy. But always keep in mind that you don't want excessive superheat that may contribute to overheating. Frosted suction lines and compressors are not a positive indication that liquid refrigerant is returning to the compressor on systems operating below freezing. There is no relation between frost and properly operating systems. The only true way you can be sure is to measure the superheat entering the compressor. So in review, the two best methods of avoiding a floodback problem are: first, measure the superheat of the refrigerant going into the compressor and make sure that it is at least 20 degrees Fahrenheit. And secondly, place a properly designed accumulator in line on the suction line before the compressor. Follow these principles and you should not experience any problem with refrigerant floodback.
As we have seen, refrigerant floodback can cause quite a problem, often detected in a failed compressor by spotting a pattern of wearing, seizing, or breaking that is more severe at the motor end bearing and lessens as it reaches the oil pump end. Floodback can be caused by low evaporator loads, overcharges in a capillary tube system, malfunctioning or improperly adjusted expansion valves, or sudden changes in load. But floodback can be avoided by following a few guidelines. First and easiest is to measure the superheat at the compressor and make sure it is at least 20 degrees Fahrenheit during normal running operation. Secondly, you can install a properly designed accumulator in the suction line just before the compressor, making sure that it has some way to return oil. Remember, replacing a failed compressor in a system with a problem will often gain you nothing more than another failed compressor. Study your entire system rather than looking at the individual components. Improper diagnosis and improper corrections will create a whole new set of problems. Proper diagnosis and proper corrections will make a world of difference. On behalf of all the people at Copeland Corporation, I thank you for your attention. For additional information on other causes of compressor failures, ask to see the other Copeland tapes in this series.